In this video, let's check whether integers are closed under the basic 4 operations of mathematics. So talking about addition, subtraction, multiplication and division. Let's check with the first one. Alright, so exactly what are integers? Integers are numbers which contain a 0, which have positive numbers like 1, 2, 3, 4, 5, and they go on. Here they don't end, alright? So, but the special thing about it is you have negative numbers, that is -1, -2, -3, -4, -5, like that. It means these numbers are full numbers. They're not half, like they're not like 1.5 and 2.5, stuff like that. And there are no fractions in this. And the good thing is that they have positive numbers and negative numbers and a 0 included. That's how you see integers as. Now let's talk about the first addition, the property or the operation addition. Let me take two integers, right? So let's talk about 5 and let's talk about a is 5 and b is 10. So when I do a plus b, that is 5 plus 10, I get 15, and 15 will be somewhere there ahead here, like 6, 7, 8, 9, 10, somewhere. 15 is there. So I can say yes, 15 do belong to z. Right. Any other example? Let's take second example. Let's talk about negative numbers this time. A is -7 and b is 3. What happens if I add them? That is -7 plus 3. You get -4, and -4 do belong to z, right? Because this set contains both positive and negative numbers. So all about it. Now I can see that if I take any two numbers, whether they're positive or negative, let's take both of them to be negative numbers. Let's talk about a is -5 and b is -6. And what is -5 plus -6? So I can see that I multiply this with -5, -6 is -11. And -11 again belongs to z. So that's all about it. So whether I take both the positive numbers, one positive, one negative, or both negative numbers, I can see either the answer is a positive number or a negative number or a negative number. So the answer is always belonging to the set, right? So we understand. Now we can say that integers are closed under addition, alright? Let's talk about the second operation here, the subtraction. Okay, let's take two numbers. Now again, a is, let's say, 6 and b is like, say, -3. And what I'm trying to do is a minus b. So that is like 6 minus of -3. So it implies that 6 minus into minus plus 3 is 9. And 9 does belong to z, isn't it? Yeah, 9's over here. Cool. Now, any other possibility? Let's take an example. A is -3 and b is 10. So let's say -3 minus 10 is -13, and that belongs to z. So I can see that any two numbers I take and I do subtraction, I am getting an answer which actually belongs to the same set z. Now if I take a to be 5 and b to be 5 again, see what happens now. So is it possible that 5 minus 5 is 0? Yes. And does 0 belong? Yes, even 0 belongs to z. So I can see all the cases, whether it is addition, for all the numbers which I take, I'm getting the answer as a rational, an integer. In subtraction also, whatever two numbers I'm taking from this set, and if I'm subtracting them, I'm getting the answer again belonging to the same set. So I can say for both of them, I can say for all a and b which belong to integers, a plus b is equal to c, where c also belongs to z. Therefore I can say integers are closed under addition. So that's what we can say. This is the language we should actually need to know, and you should write it like this. Alright, now very simple. Now if I talk about subtraction, I can see that for all a and b which belong to z, if I subtract them, I'm getting c. C is a number which also belongs to z. So I can say what? Subtraction or integers are closed under subtraction. Cool, we understand this, right? Now let's talk about multiplication. The third operation is about multiplication. So now think about two numbers and try multiplying them. So let's say 3 is a and b is 8. Now when I multiply them, a into b, that's actually 3 into 8, which is simply 24, and 24 does belong to integers, right? Can you think of two numbers when you multiply? Think of two integers, all right? When you multiply, you are not getting an integer. There are no two numbers like that. Maybe I'm taking a to be -2 and b to be 6. Minus 2 into 6 is again what? Minus 12, which belongs to Z. So I don't find any numbers, right, where I can think of that if I take two numbers from integers and I multiply, I'm not getting an integer. So I can say yes, whether they are positive numbers, one negative, one positive, or both negative, minus and minus will be plus. The answer would be a full number, and that is an integer. So again I can say for all A and B which belong to Z, A into B is C, where C also belongs to what? Z. Therefore I can say integers are closed under what? Multiplication. So there's a short form I'm writing for integers I. Now the last thing we need to talk about is division. Do you think integers are closed on division? Alright, division, let's take A is 5 and let's say B is 3. Now what is A divided by B? That is 5 by 3. Now no, this guy is not belonging to this set because these are all full numbers and I don't have anything like 5 by 3. Okay, this guy is a rational number. Now I can see when I divide two numbers, always I may not get an integer. Sometimes we may get. So for example, I say that A is 15 and B is 3, then 15 by 3 is in fact 5, which is an integer. But based on this, I cannot say for all, right? Sometimes we may get the answer, but we should get the answer for all the numbers I take. So I can say here, for all A and B which belong to Z, A divided by B is C, and C is actually not always belonging to Z. Therefore I can say integers are not closed on division. That's all about it. So we understand this simple idea of to check whether integers, the set of integers are closed under subtraction, addition, multiplication, and division. In this case we understood it is closed under addition, subtraction and multiplication, but not under division. So keep that in mind, right?